I'm going to show you a video. Okay, and I actually shot this video when I was down in San Francisco at this place called the Exploratorium. It's kind of like Science World, but so much better. Okay, so if you're ever down in San Francisco, you got to check out this place, Exploratorium. Anyways, I'm going to show you this video, and I want you to look at the shape that is created in the video. Okay, here's my video. Come on. That's so lagging. Let me, maybe if I'm going to spin. Okay, here we go. Don't worry about what she's saying. She's just trying to describe what's going to happen. Anyways, here we go, spin. Watch the water. See how the water's bending? So the question is, you know, if I was the physics teacher, what's the reason behind this? But as the math teacher, what shape do you actually see there? It's kind of like a U shape, right? Nice. So a U shape thing is something called a parabola. So I'm going to ask you to write this down. Parabola. Okay? And it's like this U shaped thing like this. A parabola. It's not bacteria, it's parabola. Okay? Now, ladies and gentlemen, this shape can also be described as a function, or I can use a mathematical equation to do this. Okay? But before I actually show you the equation, remember back in grade 10 when we learned that when we had a linear function had this equation, right? So we had a graph of the line, and it was represented by this equation. I don't know if I remember telling you this, but this has a degree, or the highest power of x being equal to what number here? What's the power of x in this case? 1. Good. Okay. Now in this chapter, because now you're in grade 11, you're more sophisticated, we will learn about what we call the quadratic function. And let me tell you, the quadratic function has a highest power that is actually bigger than 1. Okay? So, quadratic. Q-U-A-D-R-A-T-I-C. So like what Katie predicted, okay, let me tell you some properties of the quadratic function first. The first thing is this. It's a function at x that's given by a polynomial of degree 2, like what Katie said. Meaning there must be an x squared term. Okay, so you are more sophisticated now. You can do squareds. Okay? Now the shape of this function I told you is called a parabola. And the nice thing about a parabola is it's actually symmetric. So if I were to cut it down the middle, the two sides are the same. We have a special name for that line that cuts it down the middle to become symmetric. Its name is called the following. It's called the axis of, and it's symmetric, so they call it the axis of symmetry. Okay? All right. Now, with an axis of symmetry and this parabola shape, you will always have either what we call a highest point or lowest point. And we have a special name for that as well. And that's called the vertex. Okay? So here's what I like to do before I talk to you more about some of these properties of a quadratic function. I'd like you to skip 4 and 5 right now and go down to example 1. I'd like you to graph the quadratic function by hand. So no calculator right now. I want you to do this by hand. Okay? And to do so, can you please use the following x values? Okay, I'm going to say use -3, -2, -1, 0, 1, 2, and 3. Okay? Let's go ahead and plot those right now. You do that, please. Plotted the points. I have a point -3, and I believe it's 9, so that's up here. -2 is 4 up here. -1 is 1. So you got these points, and if you connected them together, that's great. May I ask you, please, though, don't stop like that. Actually continue a little bit further and put arrows on the end, because the actual graph continues further and further on. I just gave you a small sample of points, okay? But this thing goes on forever and ever and ever, okay? So I'd like you right now to take a look at the following things. What's the y-intercept? What's the x-intercept? And what's the coordinates of the vertex? Tell me that first of all. Y-intercept is 0. Good. X-intercept seems to be 0. What are the coordinates of the vertex? Remember, the vertex is either the maximum or the minimum point. Now, in this case, we don't have a max, or we don't have a max. So we're looking at the min. What is it? 0, 0. Good. Now, for the next one, D, I'm going to ask you, what's the equation of the axis of symmetry? Before we even do the equation, where would you draw in the axis of symmetry? Right, so we're going to put it down here. I'm going to ask you to do that, please, for me, okay? I'm going to put a little dotted line to show that this is the axis of symmetry. Because that's the line where if I put it down the middle there, it cuts it into 2 equal pieces. And for those of you who remember grade 10, how do you describe the equation of a vertical line? Something with 0. Good. What's the letter in front? Is it x? Is it y? It's y. Is it x? Which one? Think about it. All the points on this line, okay? For example, don't write this down, just watch. This is the point 0, -7. This is the point 0, -3. This is the point 0, 5. What's the same for all these points on this line? It's the x values that's the same, so this is x equals to 0. Okay, be careful. A vertical line always is x equals to a number. Okay. Now, we also learned about these two terms last year in grade 10, domain and range. Domain stands for all possible values of x. So tell me what the possible values of x are. How about everything to the right of 0? And also everything to the left of 0? So what do we call that? All real numbers. Yes, good. So if you're curious about the symbols, this is what we use for the symbols. We said x belongs to the set of all real numbers, and we use this sideways E. And then the R represents all real numbers. Okay, that's the symbol. Okay, but if you want to write it in words, just say x is all real numbers. That's okay as well. Okay. And the last one I want you to think about here is the range. What do you think is the possible y values when you look at this graph? Greater than or equal to, bravo, 0. Awesome. Okay. Now, ladies and gentlemen, I like chips. So I think of this as, no, this is not barbecue. This is original. Original chips. Okay, regular flavored, because this is the regular or standard parabola. What we're going to do next is we're going to spice it up by doing things to it. Okay, by adding flavor to it.
Salt and vinegar.
Salt and vinegar, ew. Okay, ketchup, yeah. Barbecue, yeah. Sweet chili, heat, yeah. Anyways, we're going to do stuff to this graph, okay? And I'm going to ask you, I'm going to ask you to see visually what happens to the graph and also look at what the equation or how the equation changes, okay? So let's turn the page, please. Turn the page. Yes. Oh, I didn't finish 4 and 5. Oh, sorry. Let's go back. Whoops. Go back. Thank you. I want you to get some exercise turning the pages today. Okay, 4 and 5. Thanks, Vincent. Okay, the y-coordinate of the vertex determines the what? So the y-coordinate of the vertex seems to be this value here, the 0, or is this value 0 here. What does that help us find? Well, it actually helps us find the maximum or the minimum value. Okay? That's here. Max or min value. Now, by the way, how do we know if it's a max? How do we know if it's a min? Well, it says this depends on whether the parabola opens the following way. If it opens down, okay, and I'll draw a picture like this, what do we get? A maximum, right? So down matches up with the maximum. If the parabola opens upward like this, what do we get? Well, that's the minimum. Okay, so make the connection. Maximum, the parabola must open downwards. minimum the parabola must open upwards. And then the last thing here, the coordinate of the vertex, or sorry, the x-coordinate of the vertex now, can be used to help determine what? Well, the x-coordinate of the vertex helps determine the, not the parabola, but the equation of the axis of symmetry. Yeah, that line. Okay? So that's why this vertex point, or this maximum endpoint, is very important. You got a lot of information from that point. Okay? Now let's turn the page. All right, here. So here's what I'd like you to do. Let's investigate. Okay, we've got our regular chips. We're going to now spice it up somehow. Let's see what happens when we change the graph of y equals x squared by changing the equation. Okay, so I'm going to ask you to pick the same x values as before. -3, -2, -1, 0, 1, 2, 3. Okay? And now what I'm going to ask you to do in that middle column is let's graph out the first one. And I'll use this one in blue here. So y equals to, let's go x squared plus 3. So I'm going to ask you to make a table of values for that one. Then plot the points on the same grid. And I want you to see what happens to the y-intercept. Okay? So why don't you do that right now? And if you finish that one, I'd like you to also then graph out the one underneath, which is x squared minus 4. Once again, a table of values. Once again, plot. And what do you notice about the y-intercept for that one as well? Okay, so take a few moments to try this right now. I'm going to try to set up this other program that I want to take a look at. Okay, so I'm going to use this program here. So I can write down y, whoops, y, whoa, what happened there? Okay, that's kind of weird. How come it's like that? Let's do a new one. Yes, y, that's so strange. I'm writing down here, but it's appearing up there. Oh, wow, weird stuff. That's not good. New again. Whatever, y equals x squared, right? And then I'm going to do this. Oh. Sorry, everybody. What? This is not good. Let's just pause the recording first. Okay. Y equals to x squared, right? What I will do now is... Come on. Nice. So what happened here is actually it graphed it for me. I'm going to open this a little bit to make it bigger. Okay, so here's your graph that connects to this. All right. I can zoom in, or zoom out, sorry. Zoom in. Okay, notice over here I click this table button and actually show me the table of values. So think about what I asked you to do, right? I asked you to do this by hand. Well, it gave you the table of values here. -3 is 9, 4, 1, so on and so forth. Okay, let me just try to make this a little bit smaller so you can see both. Yeah, I will on the graphing calculator later. But right now I just want to show you this program because here's what we did, okay? Notice what I asked you to do now is I wanted to add a particular number to the end of this. So I'm going to add something called, let's say, q. Okay? And now, what value of q did I use for your investigation? The first one was x squared plus 3. So let me just write down q equals to 3. And watch what happens to the graph. Do you see what happened? It shifted up, right? And can you see how the actual table of values also changed? So from -3 now, what's your value there? It's 12. Is that what you got? 7, 4, 3, 4, 7, 12? Cool. Now, the next one was what? -4, right? So let me erase this. And let's make it -4. And let's see what happens there. It shifted down, right? And let's look at your table of values. Did you get 5, 0, -3, -4, -3, 0, 5? Okay. Let's make it even more fun. Okay? I don't want to pick particular values like this. I want to do the following. So I want to actually show a number slider. And this is what I'm going to ask you to do now. See this slider? This controls the letter Q. Okay? So right now I'm saying Q is -4. What if I want to change it? Let's say I move it to the right. What do you think is going to happen with the graph? Okay? What happens if I go to the left? So look at my Q value as the Q value changes, right? Right? It changes your number for you. Yeah. Now, maybe you can't actually see it well, but let me just change this to, let's look at whole numbers. So I'll go D for discrete. So right now, Q is -3. As I move to the right, okay, let's say it'll be -2, then -1, then 0, then 1, then 2, then 3. See what happens to the graph, right? And if I go to the left, making Q smaller and smaller now, it's negative. Look what happens to the graph. So here's what I'm going to ask you to do in your notes. You graphed it out. What do you notice about the the y-intercept for both of these? I guess first of all I should graph this out myself. So what happened to the y-intercept for the one in blue here? Can you suggest to me what happened to the y-intercept? Compare it with the original chips. A lot higher. How much higher? Good. So it looks like it moved up. Okay, moved higher 3 units. Okay, good. What were the 7? Okay. Now, tell me what happened with the x squared minus 4 then. How did the y-intercept, and once again, we're comparing it to the original bag of chips. So what happened? It went down, or it went lower. Okay, so it moved lower by, in this case, 4 units. Okay, and if I were to do this, let's see, what was it, 5, then 3, oh, sorry, 5, 0. Yeah. Okay, thank you. So my question to you now is this, okay? I'd like you to compare these two graphs, okay? We've got y equals to x squared plus q with y equals x squared. When I add the q at the end, what happens to your graph? It moves how? Or? So what do we call that? Up or down? Starts with a V. Vertically. Good. So what I want you to understand is if I add a number or subtract a number at the end after the x squared, we move it vertically. What happens if q is bigger than 0? It goes up. What happens if q is less than 0? It goes down. Good. It's in a box. It's important. That's the first type of shift that I want you to understand. Okay? I'd like you now to move on to the next one. I'd like you to graph these two functions now. Okay? And I'm going to help you with this one. I don't need you to make an actual table of values. But I'm going to ask you to take a look at this first one, y equals to x squared minus 2. And right now, I'm going to ask you to predict what you think is going to happen to the x-intercept for this graph. Okay? So I want you to think about that in your head. And I'm now going to actually show this to you with this program as well. Okay? So let me create a new one. We're going to start with our original y equals to x squared. Okay, I'm going to show you the picture. Whoa, what happened there? Oh, I don't want c, I want x. X, my variable x. There you go, x squared.
But it's not x squared though, it's x minus 2 squared.
Okay, so I'm going to change that. Thank you. So I'm going to start with the original one, and let me change it. So let's go erase, put a bracket, and I'm going to choose a little letter. Okay, I'm going to use the letter P. Okay, squared. All right, and then I'm going to say P is what number in this case? What do I want to do right now? X minus 2, so what's P?
2.
Just the number 2. Good. Okay. Look at your picture here. What has... Yeah. Oh, I know what happened. This is capital P. That's small p. Wow, this is picky. Okay, P. That's better. Okay. So what happened to your graph? What happened to your x-intercept? It used to be at 0. Now where is it? It's at 2. So notice what I'd like you to do now is what happened to the x-intercept? It seems like the x-intercept moved which way? Moved 2 units which way? To the right. Good. So I'd like you to write that down, and I'm going to ask you to also see if you can move the coordinates all 2 to the right. Okay, so let me give you the main coordinates of the original parabola. Okay. Those are the ones you had before. This is original, right? Original bag of chips. Let's move it now 2 units to the right. So I'm going to move this vertex 2 units to the right. I'm going to move this point to the right. Move this point to the right. Move this point to the right. Okay, move them all to the right. And I'm going to ask you to try to graph out now. That doesn't look very good. Graph out this new parabola here. Okay. So that's y equals to x minus 2 all squared. Okay. And then I'd like you to see if you can predict what happens with the one underneath, where it says x plus 5. All right. And then I'm going to ask you to graph that out as well. X plus 5, what happens? Nice. 5 units. I'll try a different color here. 5 units to the left. Now, ladies and gentlemen, this part I really want you to listen to because this gets confusing. Okay? In that program here, if I'm saying let's make this x plus 5, what is my value for p? Okay. If I were to write down 5 just like this, look, it's x minus 5. That's not what I want, right? It's way over here now. Way over here. No. Where do I want to go? I want to go to the left. So the p value, please note, is actually negative 5 over here. Okay? Now, shall we do that slider thing again? Let's. So let's go get a slider. Hello? Slider, please. Show number slider. What's wrong? Show number slider. Where is it? Aww. Let's erase this. P equals to negative 5. Slider, please. Show slider. There we go. Okay. So let's slide this. Here we go. What happens if I make the p value to the right? Okay, so negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So notice as the p value goes positive, the graph goes to the right. As the p value becomes negative, it goes to the left. Let's dance. Okay. So, back to your notes now. Okay. How would you complete the blanks here? It says, therefore, comparing y equals to x minus p all squared to y equals x squared, the graph moves which way? Horizontally. Good. Okay, and this next part, please think before you answer. If the p value is greater than 0, the graph moves which way? Good. If the p value is less than 0, the graph moves to the left. Now, be careful because some students will get confused here because they're like, well, Mr. Lee, I see from above that here we have y equals to x minus 2 squared, and it goes to the right. But then some people say, well, Mr. Lee, that's a minus 2. P is negative. No, it's not. Because of how I wrote the equation, p is always the opposite sign. So note in this example here, I want you to say p equals to 2. Whereas in the other example I have, y equals to x plus 5 squared. What is my p value here? Negative 5. Because if I want to write it in the x minus form, it's negative 5. Okay, now I think you should write this down here too so that you don't get confused. Okay, and while you do that, I will graph out my other parabola to complete my notes. Okay. Okay. All right. How are we feeling right now about this? Straightforward or no? Not quite? I'll tell you, this horizontal one's a little bit weird. Okay? It's kind of opposite of what you think it should be. All right, let's turn to the next page then. No, not yet? Okay. For those of you who are ready, turn to the next page and try the next one. Okay? Try example number 2 now. Okay, and I think we'll maybe finish off this page and maybe we'll stop. We'll see what happens. Okay? All right. Shh. Katie, ready? So let's do example number 2 now. Here I'm saying, let's combine them together. I want you to graph this function. Now, before you ever even sketch this out, can you tell me by looking at the graph how it compares with the original bag of chips? So help me out. What does this plus 2 represent? Up how many units? 2 units. Good. And then my question is, what does this x minus 3 part here represent? How many units to the right? Right, 3 units. Now, I also asked you to tell me what the vertex is going to be. Now, let's just think back. For my original graph, y equals x squared, what was my vertex? What was my vertex? Look back on the first page. 0, 0. So the original one was 0, 0. And if I told you this new one, all you do is go up 2 and right 3, what's my new vertex going to be? 3 and 2. Sweet. Why is it 3 over 2?
Why is it right 3?
Why is it right 3? Because x minus 3 here, remember it's the opposite of what you kind of think.
Okay.
Minus 3 means going right 3. Okay? So, yes.
So 3 will be P and 2 will be Q.
That's right. So the 3 is your p-value. So if you want to write that down, you can. So note, the 3 is my p-value, and the q value is your 2. Excellent. So let's go ahead and plot that point, 3 and 2. Okay. And then if you're having a little struggle thinking, well, Mr. Lee, I don't know where all the other points are, well then here's what you can do. Make a table of values. Okay. And since you know that 3, 2 is your vertex, I'm going to ask you to put that in the middle and just pick a few values of x before it and pick a few values of x after it. So I would pick maybe 2 and 1, and then after that 4 and 5. Okay, and then I'm going to ask you to once again find the y values, and then you should be able to plot the graph. Okay, try that. Oops, I forgot to record that part. But anyways, for those of you listening online, just copy what you see in the board. And then your job online is to graph out the 3 graphs in investigation number 3. Okay, so here's y equals 2x squared. Now, notice for the next one, in green, y equals to 1/2 x squared. What am I doing with the y values? I'm just taking half of the x squared values. So I'm just taking half of 9, so that's 9 over 2. Half of 4, which is 2. Half of 1, which is a half. Half of 0, 0. And of course, these are just the same, symmetrical. What's 9 over 2 as a decimal, by the way? 4.5. Okay. So watch as I graph these out then. Negative 3 is 4.5. Negative 2 is 2. Negative 1 is 0.5. 0. So notice this one seems to be a little bit wider. Okay. And then what happens with the last one here? Notice it's just the same thing as 3, except there's a negative sign. So I just want to make everything negative. Negative, 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 negative. Negative 4.5, way down here. Negative 2, negative half. So ladies and gentlemen, I've actually now shown you what happens to the graph when I put a number in front of the x squared terms. Once again, please label your graphs, because I did not do that. And then I hope that your notes now look like mine. And I think what I'll do is just go to the little program and show you that. And I think I'll stop for today. Oh no, maybe I'll finish the blank underneath and then I'll stop for today. Okay? I know I'm kind of going slow right now, but I really want you to get a good visual representation of what this is about, okay? And that's why I'm spending time with the computer program to show you the different ideas and the flexibility of what's going on. Okay? Bless you. Okay, so let's go to this one. I will graph out y equals to x squared again. Hello graph. That's so cool. In this case, I'm putting a value of a in front, right? Uh-oh. No, 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 no. That's not right. No, 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 no. A. Good. A equals to 1. Fine. 2. Let's do 1. Okay. Let's make this a little bit bigger. Okay. Let's make my slider. Cool. And notice what happened when I made it 2. Look what happened. 2, I went like this. So you see how the graph went from regular to, these are the reduced fat chips. Get it? Thinner. Get it?
No.
Let's reduce it even more, right? Let's go up to 3. Even thinner. Even thinner. Here's anorexic. Anorexic, okay? All right, now, what happens when I go a little bit less? So let's see what happens when it was a half. So notice what happens, okay? Watch. From 1 to a half. Let's see what happens. Okay, so notice it. This is 1, and it became a little bit more wide. So what happens when I get closer and closer to 0? It gets even wider and wider. Okay? This is the extra flavor, right? What's the most like calorie chips? The works. I'll call it the works. Sour cream and onion and everything else. Okay, now look what happens when I become negative. Okay, so watch, 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 and then all of a sudden it becomes negative. Right? So it's now down here. Woo! Woo. This is like it's like a bird. Look at it. Back and forth. Back and forth. Bird. Okay. So what happens at 0? Okay, what do you think happens at 0? 0 times x squared. What's that? 0. So what you really have is y equals to 0. So let's take a look what that is. Okay. Straight line. Right? Let me change it to 1. We got the parabola. 2 got a parabola. 3 got a parabola. And then at 0 we got straight line. And then what's negative 1? Parabola again. Okay? All right, ladies and gentlemen, let's finish off your notes. Comparing what happens to the a value now. If a is positive, which way does the graph open? Up. Good. Up. Right? Look at all the values of a for these ones here. They're all going upwards or opening upwards.
What do you mean open upwards like that?
Open up meaning where is the opening of the parabola? It opens upwards. How about if a is negative? You're turning it upside down. So where is it opening? It's opening down. Graph opens down. Now, here's an important part. Have you seen this sign before, the absolute value sign? Sort of, not really. That means just ignore the actual sign. So I'm just saying look at the actual number. Okay? So in this case, the absolute value of a for number 2 is 2. The absolute value of a for 3 is a half. The absolute value of a for 4 is just a half. So ignore the negative. Okay? So when that number is bigger than 1, so that's the case in yellow there, the graph becomes thin. Okay? Remember? Reduced fat chips. Thin. Now, we do not use that term in math because that sounds really bad. So we have a special name for it.
Slim?
No. Anybody here have a hairband, hair tie?
No, but
Can I borrow one really quickly?
no, I don't.
No?
Oh, no.
Can I borrow these? You have a hairband? Okay. Ooh, Elle has one.
Yes.
Okay. Can you, if I hide this part, can you see how there's a parabola here? Can you see parabola? Now, how do I make this thin? Well, here's how I do it. I stretch it, you're right. I stretch it which way? Vertically. Or I stretch up, okay? I can stretch up. See? Very thin parabola now, right? So what I want you to understand is when I get this, the graph is thin, I'm saying it is vertically stretched, but when I stretch it up, I'm actually expanding it. So it's called vertically expanded. Okay? Or you can say stretch up. Expanded, E-X-P-A-N-D-E-D. Okay? Now, the next part here, if a is less than 1, let's see what happens, okay? I'm not stretching it up anymore. What am I doing?
Making it fat.
Making it fat. How do I make it fat? I have to kind of push it down, right? See how I push it down, it gets fat? So what do we call that when I go pushing it down? It's this. It's called a vertical or vertically squished. What's another word for squished? Compressed. Not repressed. Squished. Okay? Now, ladies and gentlemen, you can use the terms fat and thin with me, stretched or squished, but technically the correct mathematical terms are vertically expanded and vertically compressed. Thanks, Elle. I need to get my own hairband. Okay? Now, ladies and gentlemen, the next page is a summary of what we just did. Okay? I'm not going to do that right now. I'm going to save that for next day. So I'm going to stop here. But what I will do is I'm going to try to show you all three of these things on that little program. As for your homework tonight, I'm not going to assign any homework from this section. I just want you to kind of listen to this. When you do, or when you come back 2 classes from now, I'll continue the notes with you then. All right? Your job tonight is just study for your test on Friday. So let me see if I can get this done. And hopefully this will work.